Alright, welcome to my channel. Good day to all of you. Today, I'm going to show you a method of creating socket head cap screw. There are many ways of creating this, and this is one of my method. Okay, so if we're going to look at here, with the basic profiling, okay, so we have this minor diameter, pitch diameter, and the major diameter for the threading. Okay, so the pitch is a distance between two threads. Okay, so it has an height, and the tip is divided by 8 and the bottom is divided by 4. So we have this center axis of the thread. This is for the external side and this is for the internal side. Okay, so there is a standard of getting those dimensions, especially this h, this height. So in order for us to get this, there are various formula here. Okay, so we try this, calculate this in order for us to get this h. Okay, so 3 square root divided by 2 equals to 0.8660254, same as this value. Okay, so that is how it was being derived, and you multiply it with the pitch. Alright, so for now we're going to create this M6, a metric, this dimension. Okay, so we will take the M6 and the thread is for the course is 1 millimeter. Alright, okay, for the socket head cap screw dimensions, if you're going to go to this roymech.org, it's based from the UK, so you will see this dimensioning. So for us, we will get this M6. We are going to follow this. Alright? Okay, let's start. Okay, new part. We're going to create the material. We can use stainless steel, alloy steel, whatsoever. Okay, so for us, we're going to use the alloy steel, this. Okay, the color depends on you, whatever based on the standard in your company, or you know. So for me, I basically use this particular RGB value for the socket head cap screw. Okay, now the next thing we're going to do is we're going to create some equations in order to help us do the part later on. Okay, so we're going to create a variable. M stands for M6 for the metric size. Okay, and then we're going to follow it by the pitch, which is 1 millimeter. Okay, M6 pitch 1 millimeter. Okay, so we're going to create this height, this head, the socket wrench sizes, So we will do this. Okay, so we're going to do thread height. Thread height will be 0.866025 multiply by pitch. Okay, there you go. So that was the thread height. Okay, thread height is this H. Remember, we get it from this value. Okay. Okay, next we're going to do for the A, the socket head diameter, which is 10 mm, and then the head height, which is 6 mm. Show you. Okay, 6 and 10. And then for the hex socket size is 5 mm. Alright, the depth 3.3. Okay, so we're going to do the J, which is a value of 5 millimeter, and then the K, 3 mm is okay. Okay, we have these variables already that we can start to create our socketed cap screw. Okay, so now we can start creating a part. Okay, so we are going to create some construction lines that we will be needing in creating the socket head cap screw with some thread. Okay, so just create this, and this to this. Okay, and this to this. Okay, then we're going to create the pitch. This is for the pitching. Alright, so we can now dimension this. Okay, in order for us to go to get the global variables, you have to press the equal sign, select this, and select pitch. Okay, you see the equation variable and the equation here. Alright, so we're now going to do this and this. This is the size of the thread, which is the M6. So press again the equal sign, global variable, and M6. Okay, now is we go to this and this, press the global variable, and that is the thread height. Okay, so we zoom in. So we try to move this, this, and this. Okay? Now, we are going to create this. H divided by 8, height divided by 4, 3, H divided by 8 to get the pitch diameter. Okay? So we proceed. So from here to here, it says press the equal sign. Okay, the height, you divide it by 8. Okay, from here to here is equal sign height, thread height divided by 4. In order to get the pitch diameter is height times 3 divided by 8. So global variable height times 3 divided by 8. Okay? Okay, so we try to constrain this to here. Alright, so everything is constrained already. So, we have the variables that we have created. Okay, we are now going to draw this line. Okay, so line, we are going to get the construction line. Sorry, you can point it anywhere, doesn't matter. Okay, so we can zoom in and connect it here, constrain it here, constrain it here, and then this to here is equal sign pitch divided by 2. Okay, okay, sorry for this. We're going to constrain it here, this to here. Alright, so everything is already constrained. Right? So we're going to go now to the next step. Alright, so now we are going to create the helix or the thread itself. By doing that, okay, so we will be needing the so-called okay, the shape. So go to the right plane. Okay, create a circle. Okay, try to change the view. Okay, so this circle and this make it coincident. Okay, that is the minor diameter. Alright, so okay, let me go back so that it will not confuse you. Okay, So this one is to here. Yeah. Okay. This one here is the pitch. Yes. Pitch diameter. Okay. From here to here is a major diameter, and from here to this edge is minor diameter. Okay. Okay, we go back. So after creating this, we are now going to do the extrude. Select this, then reverse the direction. Okay, and we are going to do another global. So create it as equal, and then we write length is equal to 25. Okay, we're going to add another variable, which is the length is equal to 25. Extrude, reverse the direction, equal sign, select length. Okay. Okay. Now, after creating this, we are now going to create the thread. Okay, to do that, we are going to select the curve, helix, and we're going to select this face. Okay, then convert entities, select this edge, then okay. Alright, then exit. Okay, we try to change the view. First is we're going to select height and pitch. Okay, for the height, we're going to make it 28, and then reverse the direction using the pitch of 1 millimeter. Clockwise, change this to 90 degrees so that it will correspond to the sketch that we have created for the shape of the thread. Okay? Okay. Now, we have the helix for the thread. Okay? So, the next is we are going to change these variables. Okay, and we are going to change this pitching also. Double click on it, is equal sign, is pitch. Okay, for this length, we are going to get the length plus 3 millimeter or 2 millimeter. Okay, zoom. Then we are going to create the thread sketch. Okay, go to the front panel, and then we're going to create the sketch. Just draw a line. Don't worry about the dimension. Okay, then you click this line, press the control key and click this and make it coincident. Click this line and this line coincident. This end, control key, this line coincident. End point, this line, control key and coincident. And then exit. Change the view. Okay, we zoom in a little bit. Now what we're going to do is we're going to sweep the sketch that we have created. Okay, sketch 4, and the path is the helix. Right? And then okay. Okay, we're going to hide this helix. So now we can hide our first sketch. Okay. Now we are going to remove the extra threads. How to do that? Okay, we're going to select the front panel, make a sketch. Okay, down here we are going to create a line from here to here, 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 and then close. Okay, we are now going to dimension it. From the major line to here, it's 0.25. And then from here to here, the angle will be 55 millimeter. Or it's too much, we make it 58. Okay, 60. There you go. 60 is quite okay. Don't worry about this, or if you want, we can dimension that as well. Okay, make this 2 mm. Make this distance 1.5. Okay, and then we're going to create a center line from this point to here. Okay, and then we will do the revolve cut. Click the revolve cut and click OK. Wow, see, it creates a chamfer and it removes the extra thread. Right, same goes with on the other side, but this time we are going to select this face, make a sketch. Okay, Okay, we just zoom in. Alright, and then we're going to create a circle. Okay, we constrain it, we click this and this, we make a 2 mm distance. Click OK, and then go to the feature and do the extruded cut. You reverse it, make it through hole. Okay, there you have it. That is the initial thread. You see? Now we are going to create the head. So to do that, we are going to click this surface, this face, and make a sketch. Okay, so I'll just probably hide those dimensions. So we are going to create a circle. Alright, and then we're going to dimension this. Again, press the equal sign and we select the A for the head diameter. Okay, we exit, and then we're going to extrude. Okay, exit, feature extrude, change the view. Now for the size, we are going to press the equal sign and then H. Okay, there you go. Press the space bar, rotate, and then we're going to create the hex. Click this surface, polygon, center line, select, make this vertical constraint, and then for the size, okay, equal sign, global, and the J. Okay, exit, extrude cut. Okay, for the distance, equal sign, global, and K. Okay, space bar to rotate. Okay, now we are going to create just one more thing, is cut extrude. Alright, so to do that, we're going to create a sketch here, create a circle, and to the end point. Exit, cut extrude. We're going to do the draft. The draft angle is 60 degrees and the depth 10. Okay, we are going to see if okay, this direction, and then click OK. You see, it creates this. And then lastly, we are going to create chamfer of 0.3 millimeter. Select this and select this. Okay, there you go. We have now our M6x1 socket head cap screw And that is the way how to create a thread by using the parametric. Okay, so on our next video I'm going to teach you how we can use these settings to create multiple thread sizes. Alright, thank you guys. Subscribe to my channel so you will be notified for the next video. Alright, thank you again and goodbye.